Okay, well, I'll go ahead and get started. People will file in as they can, I'm sure. I wanted to sort of do a grab bag of topics tonight. We'll see how far we can get. I will say once again, I don't expect this to take the whole time, so we'll see if that is true for once. We are, I think, not quite halfway through the semester. We've gotten into some interesting stuff. I was able to grade, I think I'm caught up on grading actually. It was really interesting looking at the different ways that people solved the project that you guys just turned in. I wanted to talk a little bit about the number systems project, just to give you a little bit of math stuff. You know, when we talk about number systems, let's talk about decimal. We have digits, you know, each column of a number. You know, this is just us humans talking. We've come up with this convention of how to represent numbers. You know, if you were living back in the Roman Empire, they used Roman numerals. That's why we call them Roman numerals, right? Completely different convention for representing numbers, but you know, as long as it's a one-to-one mapping between the concept in our head of, you know, I have 18 apples sitting here, and I have some combination of symbols that I can use to represent how many apples there are, then I can talk to other people about it, you know, as long as we all understand. So in our system, you know, we represent numeric values with decimals, and you know, if we want to get really formal about it, the first, or I guess the last, the digit of least precision is what we call the ones position. And I've got 9 ones in this number. So 9 times 1 equals 9. That's how many ones I have in this column. I go up to the next digit, and that is what we call the tens digit. Because, as you guessed it, I have 8 tens represented in this number, and so on. You know, I have the hundreds position next, so I have 7 hundreds represented in this value. And if I add up all of the value in each column, each digit, times the value represented by that column, you know, the ones, tens, hundreds, thousands position, and then I add up all those representations, then I get the total sum, which is the value that I'm trying to represent. Now, this is decimal, breaking down decimal and adding up all the numbers so that we can represent that number in decimal. You just go in a big circle and we come back to, well, that's the number we're trying to represent. So big surprise that adding up all those numbers times the position that they represent equals that number, because it's sort of by definition. But when we go to some other numbering system, like binary, now the rules are slightly different. Although we use the same convention, we just make a couple of significant changes. If I'm going to represent a value in binary, I'm only allowed to use digits 0 and 1. Whereas up here in decimal, I can use any digit 0 through 9. Okay, so if I have a number like this, all of the digits there are legal digits to use in binary. I can also name my positions, once again, this is the ones digit. I either have 0 or 1 ones. But what do I call this next position? Well, that means we need to go back and understand why we picked tens and hundreds as the names of the positions up here. Well, the ones position we get because it's 1 to the power of 0 is 1. The tens position is 1 to the power of 1. Oh, wait, not 1, 10, because we're in decimal, which we can also call base 10. And it's base 10 because we have 10 legal digits that we can use in that numbering system. Okay? I'm being very pedantic about this, but you'll see once we understand why we count the way we count, it makes changing to other bases a lot easier. So hundreds is 10 to the power of 2, and so on. Each digit column that I go up increases the power of 10 that is represented by that digit. So when I come down here and fill in these numbers, let's see, binary, that's going to be base 2 because I have 2 legal digits. Okay, so we call it the ones digit because it's 2 to the power of 0. Then what do we call this? Because it's going to be 2 to the power of 1, which is 2, right? So we're going to call this the 2's position. The next one is the 4's position. And so on. So, now this is where it gets fun, because now I can convert the digits represented here into what we're familiar with, decimal. All I have to do is multiply the value in that column times the value of the column it's in, and then add them all up. So the first one, the highest one, is going to be 128 times 1. I just quickly did the math in my head, the powers of 2. 2 to the 8th is 128, right? Or 2 to the 7th. So this is the 8th digit, so it's 2 to the 7th. If we keep counting up here. So this is the 128th position. So 128 times 1 plus 64 times 0, which is going to cancel out to 0, plus 32 times 1, plus 16 times 1, 0 times 8. See where I'm going with this? Did I lose anybody there? 1 times 4 plus 1 times 2 plus 0 times 1. And so if I add all those up, what do I get? 128, 160, 176, 180, 182. Did I do that right? So when I think of converting between numbering systems, binary, octal, hex, all I'm doing is taking what I know about the rules of decimal, taking to their logical extreme, and then replacing the base, the list of legal digits, renaming the columns for the value that that column represents, and then I just do the math. I sum the weight of the column times the digit in the column, add them all up, and the sum is that number in decimal. And that works that way because notice in this formula we switched from binary back to decimal in order to do the math. That's why I'm using 128. 128 is a legal decimal value. I'm not saying 1,000,000,000 times 1, because then in order to do the math I have to convert it back to decimal in my head because I'm a human and I have 10 fingers. Okay. But you know, in decimal this is 128 for that value. Does that make sense? And so knowing that, if you go back and read the assignment carefully, maybe it'll make a little bit more sense, that table that I was talking about for each of the number systems. And if you haven't figured out yet, this is kind of a theme with me, is that I tell you to do something confusing, and I confuse the heck out of you and leave some things out and make you ponder about it, because my understanding of neurology and learning, and has held true myself, is when I'm initially confused about something and become curious and I go hunting for the answers, once I find the answer, it sticks better than if somebody just tells me in a lecture all the answers and I just go away like a jigsaw puzzle and try to fit all the pieces together. Fine, I may figure it out, but I'm not going to remember it as well. You know, if you guys were, you know, in 5th or 6th grade, I wouldn't explain that concept to you, but as adults, I feel free to tell you why I'm doing what I'm doing. You know, because at a certain point, you can use these tricks to help yourself learn topics also. Don't just look for the answer. Try to solve the puzzle first. Figure it out on your own. Make your brain do some work. And you know, you'll be more likely to remember it later. Do you want me to do octal also? I'll start octal, which is base 8. We have the legal digits 0 through 7, because we can only have 8 of them. So, like before, we're going to have a ones position. We always have a ones position because any number to the power of 0 is 1. What's my next position? Okay, that one was maybe easy to guess. What's the next one? It gets big pretty quickly when you're doing higher level bases. So the next position is the 64's position. And so on. Okay, so if I have something like 1, 4, 6, and that's an octal number, it's not 146 decimal. The way I would figure out what that is in decimal is, well, I know that that's the 64's position, so 64 times 1 plus 32 times 4 plus 1 times 6. So that's going to be, I would have had to make the math hard, wouldn't I? I think that's 198. But once you plug all these differences in for the base, then the algorithm is exactly the same. And I guess that's the reason why I thought it was an interesting program to have to write. I wanted you to see, how can I write some really tight code, an algorithm for this problem, where I don't have to rewrite the code every single time I want to use a different numbering system. You know, you should be able to invent your own numbering system. Let's say you only want there to be 6 legal digits instead of 8. You know, by changing these values, you should be able to come up with your own numbering system, right? Or you could come up with a really big numbering system. And like let's say we wanted to use every character of the alphabet plus all 9 digits. So we could have a base 36 numbering system, right? And it turns out that there's one really useful numbering system, base 64. Has anybody ever heard of base 64 encoding? Okay, so 64 is a power of 2, so that makes it where we can use an even number of bits to store it. But it turns out you could take a document and all of the characters that we have in ASCII that we can use to represent that document, we could encode them in base 64, and it's actually a decent poor man's compression algorithm. So read up on that a little bit. But if you know how to do this, you know how to do base 64 encoding, because it's the exact same algorithm. It's just that you have 64 legal digits to use in that numbering system. Okay? That might be a fun one for me to try at some point, but I figured I'd start with something easy first, and there's lots of examples of how you implement the algorithm of base 64 encoding online. So anyway, so that's what I was hoping you would do with this assignment, is try to come up with a Java algorithm for whichever one of these base numbering systems that you wanted to use. Try to let people enter decimal and spit out that table, or vice versa, as specified in the assignment. Any questions about this algorithm? So that when you walk away and you're staring at the screen instead of a projector, and you have to do this on your own, you think, wait, what was it that he said? Happy to clarify anything now. And I'll leave the hexadecimal one to you, not only because trying to multiply powers of 16 is, I can't do it in my head as easily, so. Okay, next grab bag of topics. I wanted to talk a little bit about the unit conversion program. saw some really interesting implementations of that, and wanted to just kind of talk through some stuff. Class, yeah. Let's see if I can get it to build first. Okay, I remember now I've got to go to settings and scroll down to the use the wheel change font size with control mouse wheel. Okay, there we go. Maybe one of these days I'll get them to put that in there. Let's see if I can build this and run it. Yep. All I did was created a new project and added a source file called unit converter, which should be a file called unitconverter.java. Yeah. And added a main function to it. So, just sort of how I try to start out every program with a welcome message and a thank you message. Just a good habit to get into, so you have a good demarcation for where your program begins and where it ends. And when you run it, then you get a confirmation that, yes, my program started and finished and exited gracefully. So then, as you learned, we have to have a scanner in order to process data from the console, so console applications. So we're going to get input. And let's see, how fancy do I want to get? How about if before I answer this question, I will go to the function that I want to create. So I know that my main function, I don't like to put too much logic into the main function for what the program's going to try to accomplish. I like to limit what's here to console input and output as much as possible. Now that doesn't mean I can't have helper functions that go off and format complex tables of output given stuff that I pass it, or gather input in ways that are repetitive and common that I want to reuse. We're still able to flex our skills at creating reusable code, but I like there to be a demarcation between this is the code that does all the input and output and interfaces with the user, and this is the code that does stuff, that does work. And so at some point here, I'm going to have a units from, a units to, and a value. And I want to convert from this to this. So I've got to ask the user, what units do you want to convert from? And there's a lot of different ways that I saw that people implemented this. You can give them a list of different units, like 1 through 10 or 1 through 5, whatever, however many different unit types that you have, and they can pick a number from that list. It's pretty fair, reasonable. I saw people ask for a string, inches, and there was one person, I don't remember who it was, that allowed you to use multiple different words. So IN, INCH, INCHES, all of those counted as inches unit. I thought that was pretty clever, very user-friendly of you. I'm going to do the integer root. Because I want to show you something. Trying to do this in a structured way. It's user-friendly to I can say 1 inches, 2 feet, 3 etc. And obviously I want to do some data validation to make sure that they printed something legal. But for now, I can just leave it as that. I'll copy and paste this down. And we'll just leave that as integer also. So I didn't have, I guess I need to declare some variables, right? I can just say int. Does that sound reasonable so far? I don't see any red squigglies, so the editor at least thinks I'm doing things sort of kind of right. I should be able to run it at this point. It doesn't do anything, but it should at least get my inputs. Sure. Enter the units from 1 to 54, and it exits. So it does correctly get my units, or get my values, my input from the user, and then doesn't do anything with them and exits. So this is the next part where I want to actually I should probably make this a float or a double. I think most people use double when you did this, but unless we're gonna make it support really huge numbers, float is probably sufficient. And I could write all the code right here to do the calculation, but I want to have practice using functions, and for a reason that I'll show you later. So I'll say function units from, units to, units convert, and it's going to return a float for units converted. Now notice it's red because there isn't one, and this is a cool thing about the editor. I can right click on it and say refactor not refactor, generate, where is it? Create method convert in unit converter. That's the one that I want. And then it's going to say, okay, you want it to return a float? Yes. You want it to take parameter types? You like all these names? Yes, I like all those things. And it creates the shell. Now, to me, this is old school, helpful editor stuff. This is not AI, right? It didn't implement it for me. It didn't say, wow, reading the context of the program that you're creating, I assume that you want this implementation. I didn't use any features like that. All I used is the editor tools to do the text editing to insert those characters for me, so it's a little bit less error prone and helpful. So now I have a convert function that takes those three parameters and returns a float. So now this went from red to white, and I can say when I get back, of course it's not implemented yet, but I can say the converted value is units converted. And I can change this to format it as a decimal, which I saw some people do that and some people didn't. But to me, it's helpful. And when you're doing a decimal value to the console or to output that's a dollar value, obviously 2 decimal places is usually appropriate. Something like this, maybe 1 decimal place, 2, 3, depending on how you're using the program and how precise you need it to be, would be appropriate. So you could print that float value with, maybe 1 to 3 decimal positions. Letting it print it with 8 decimal positions is a little overkill, and it just shows like laziness, I guess is the best word for it. So I'm going to be lazy here and play the instructor card. But now I have to implement this. So instead of just returning 0 like it does, I need to do the conversion and return the converted value. Now we haven't covered if statements. That's like impending. When we're going to go through all of the switch and if and else, all those type of constructs in Java. That's going to be for the next assignment. So that might have been a hint that either, like I said before, I wanted you to go figure that out without me telling you how to do it, you know, just based on your intuition of what you learned in Python and other languages. But there's actually ways to do this program where you don't have to use if statements. And that gives me an opportunity to make the point that there's a sort of a truism. I think I mentioned before that really thick book called, it was by Michael Abrash, called The Graphics Programming Black Book. And he discusses how to optimize your code for various processors. Now those are all antiquated processors, but it's still good to study to understand historically the techniques that the CPU manufacturers used from generation to generation of CPU to try to improve the performance of their CPUs and against their competitors and against their previous version and things like that. Very interesting stuff from a hardware point of view. But knowing those techniques helps us write more efficient code. And it turns out that anytime you can write your code without an if statement in it, it's automatically faster. And we talked a little bit about the Spectre and Meltdown vulnerabilities that the Intel and AMD processors had, you know, 5 or 6 years ago that caused everybody fits, and is one of the reasons why, if you realize you have an older machine and you can't upgrade it to Windows 11, you have to buy a new machine. That's one of the reasons, is because the machines that you can't upgrade typically are built with processors that have that Spectre and Meltdown issue, and Microsoft, I think, just got tired of carrying Intel and AMD on their shoulders and don't want to support that bug anymore. They want you to buy a new CPU from them that doesn't have that bug so that they don't have to mess with it in Windows. But, and we talked about the fact that the dynamics of that bug was that if you are trying to pipeline and execute a list of instructions all in one clock cycle, and you get halfway down there and you have an if statement that says, if you have permission to read this data, then do the next instruction. But if it's trying to execute all of those instructions at once, it might actually access that data before it was cleared to have access to do it, and that caused potential and real vulnerabilities. Potential is the vulnerability, the exploit is the realization of that vulnerability. So, yeah, so the reason why that vulnerability existed is because if they could ignore the if statement and just execute everything that came after it, their CPU would be faster because it would be executing more statements at a time. The problem is, even without that bug, if the CPU gets to that if statement and says, I'm going to guess that most of the time the if statement returns true, so I'm going to load the instructions that follow it along the true path. Well, if it gets to that if statement in reality and it evaluates to be false, all of those instructions on the true path that it evaluated have to be thrown out. They're invalid, they're meaningless. They were hypothetically what needed to be executed, but not reality what needed to be executed. Now they have to stop, and they have to go back and load all the instructions that were on the false path, and then have another clock cycle execute those. I guess technically they could do both, right? Maybe some engineer at some point will get smart and say, every time we hit an if statement, we're going to load both paths and execute both paths in one clock cycle. But to my knowledge, they haven't done that yet. So yeah, every time you hit an if statement that evaluates to false, you're making your code less efficient. So why have if statements? So if we have something in here that says if units from equals 1 and units to equals 1, return units convert, else, and each time I have there's combinations of these things. If I have 5 options for units, and they can use any of those 5 for from and any of those 5 for to, then I have 25 if clauses to evaluate here, right? That's a lot of code. And I saw some people actually, you did every permutation of from and to. It's correct logically, but it's a lot of if statements. And that gives me the opportunity to point out that there's a better way to do this. And the calculation we're doing here, the whole point of this is we know that there's something we can multiply. We can multiply units convert times something to get the value that we need to return. And you guys figured out what all those values were. So I'm going to come up here and factors. I think I can do this. Let me see if I've got those factors here. Oh, actually I want these to be flowed, don't I? So from inches to feet is 12. Inches to cubits is 18. Did anybody have fun trying to look up how many inches there were in a cubit or how many inches there were in a step? Where did you come up with the numbers to use? Did you just Google it? How many inches in a step? Okay. So I came across steps actually when I was working on a project for Princess Cruise Lines. And if you've been on a Princess Cruise Line and done the medallion class where they give you a little medallion to wear and it tracks you all over the boat. Sorry, I'm trying to type and do this at the same time. Why is that? Oh, yeah, that should correct itself. Anyway, one of the things that I needed to do was figure out the route from where they were standing, where they were geolocated on the ship to whatever destination they wanted it to go to, the casino, the pool, back to their cabin. And okay, so that was one problem, is to figure out what is the interconnected path, using Dijkstra or the A-star algorithm. There's a number of different pathfinding algorithms that you can look up that you can use to solve that problem. That was interesting enough. But then how do you relay that to them? And so what I used was steps, and it turns out that is an old English unit of measurement, that there's a defined step. And if you tell somebody, well, it's about 25 steps from the desk to the door, people know what you're talking about. There was a little ambiguity because some people say that a step is 2 footsteps, and some people say it's just 1 footstep, close to the 3 feet. And so this 30 inch, it's slightly less than a yard. So 30 inches being a step is a half step, I think, in Roman terms, because I think Romans would, left, right is 1 step, left, right is another step, left, right is another step. But that wasn't as useful, and I didn't figure it would be as well understood, so I used, just each single footstep. Okay, the cool thing about this now is I have an array of factors and I can say units from and units to. So first I want to convert the units from to inches. So the units to convert times factors. So that'll get me to inches. And then I want to divide by units to. Yeah, and then return units converted. So I used a little bit of cleverness and was able to do this conversion with no if statements. Isn't that nifty? I'm not trying to just brag and, it's not an ego stroke opportunity, but what it is a reminder to keep that in the back of your head when you're coding. Just ask yourself, is there a way I can do this code without using an if statement, without using a conditional? And if I can, that's going to run a lot faster. I mean, there's some elegance to the fact that it's only 3 lines of code. Yes, fine. But the main thing here is that there's no if statement. It just flat does the conversion. Now let me see if I try to run this, if it'll tell me exactly what that error is or if it fixes it. So I'm doing something here syntax-wise. Anybody catch me on this? What's going on here? See, I thought I could just do it like that. What am I doing wrong? Required type int? No, I don't want int. I want floats. Float. See? Oh, I know what it is. I want the curly braces, not the square braces. There we go. Yeah, I know it's redundant, so I could just say return. So I got it down to 2 lines of code. Let's see if it works. Okay, convert from inches to feet, 24, 16. Okay, so I did something wrong. Probably backwards. I'm probably dividing instead of multiplying. Inches to feet, 24, 36. Okay. You know, my degree was basically a math degree with a bunch of programming classes thrown in to call it computer science. So I should be better at this math stuff. So if I enter 24, I want to divide by 12. So that's going to be 2. Oh, you know what it is? It's an off by 1 error. So I had it right the first time. I thought I was wrong, but I was mistaken. There we go. 2.0. So all you got to do is put in your conversion factors and update your prompt, and off you go to the races. Pretty cool, huh?
Can you scroll down again so I can take a picture?
Sure. This one? I mean, I realize I went through that pretty quickly, made a couple of mistakes along the way, but barring that kind of stuff, do you understand how it works and why it works? So the 24 times 1, because inches to inches is 1, divided by 12 inches to a foot gets us 2.0, so that's what we return. And I didn't have to use any if statements. That's the cool thing. Okay, another thing that I want to show you is a thing called unit tests. Let's see if I can do this. It's been a while since I've added unit tests to a project in JUnit. I think my guess is I have to add a folder to put the unit tests in, and then I have to mark that folder as a folder that contains unit tests. Let me see if that's close to being right. So I create a folder called tests. I right click on it, mark directory as test sources root. Okay. And I right click on it and say new. There's nothing down here that says test, is there? So I'm just going to create a new Java class, and I'm going to call it unit converter test. And that's a convention. We usually use the name of the class we're going to test and just add the word test after it. It's just a plain old class. And then we can add just a bunch of methods to it. We don't need a main method. But we're going to have a bunch of methods in here like void test, and then we give it a name of an equivalence class. Such as that. So when I talk about unit testing code, there's lots of different ways to test software. There is run your program and put a monkey in front of a keyboard and have them bang, 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 and you feed them a banana once in a while and they keep banging on the keyboard. That's completely random and typically very inefficient, but sometimes catches things you wouldn't otherwise if you weren't doing random testing. Okay, that's one kind of testing. Another test is just, regular smart human-based functionality testing, where you as a person, well, why don't I hit the tab key or click in certain areas, or do things that my intuition tells me might be common sources of errors with a program of this type. And another form of testing is unit testing. Unit testing is basically saying, I have a controlled environment and one function at a time, or you at least try to go to the lowest unit of code possible and test just that one piece of code in isolation. You know, if we could, we would test every single line of code in isolation, but typically we suffice it to say it's good enough to just test each function that we created. And the function is a good unit of testable code because it's got a contract. You pass in these type of parameters and it's supposed to return this type of a value. And we can flex that by passing in values, trying to find bugs, and see if it produces the correct value when it comes back. So when I name this test 0 values passed in, I might want to do something like unit converter, create a new unit converter object, and then, oh, I need to make it public. My little converter thing. See how it got created by private by default? I need to make it public so that unit converter test can see it. It returns an int. And then I just check, did I get the right value? What is it complaining about? Oh, because it's static. Yeah, I don't have to create a new instance of it because it's static. I can just say unit converter dot convert. Now what's it complaining about? Oh. There we go. The editor is very helpful, isn't it? So if I pass in all zeros, I should get 0 back. I'm converting 0 inches to inches, so I should get 0 back. Well, actually, no, that's not right. But let's go with it. I know what I'm going to get, but I don't want to give that away. Okay. I have to do a couple of stuff here to make this a valid unit test. And I don't have this memorized. But we're using a library called JUnit. I don't have that in my project yet. There's a couple of different versions of it. Let's go with the newest version. And that's all I had to do. I right-clicked on the little red thing. It had said that the JUnit library, that wasn't part of my project yet. I had not imported that that package into my project. So I right-clicked on it, and the editor went and found where that project is. So there's 2 different versions of it. Which one do you want? I picked the one I wanted, and it did all the wiring inside to work that out. Now it's there. But what these do, I mean, I wanted you to see that this is nothing more than a Java class with some functions in it that calls another Java class with functions in it. That's really all it is. What we get from these things up here is just some helper functions that are really convenient. Like, did I get the correct value back? Well, a nice way of doing that is to use the assert equals method, and I pass it what I got, and I tell it what I'm expecting to get. And it will throw an exception if it does not test these. Oh, wait. What did I do wrong there? I don't think I want the delta. Oh, expected and actual. That was helpful of it, that it told me that I had those in the wrong order. I'm not going to use the 3-parameter version of that. So apparently assert equals is overloaded with a whole bunch of different ways that you can call it. I really just want to use the simple one that says, I expect to get 0 back, and here's what I got back from the function. So when I run this code and it calls the other code, if it doesn't get 0 back when I pass all zeros in, then this will throw an exception and it'll tell me that it failed that test. It tested that method and the test failed, so there's something I have to fix. Let's see if I can do that. Right click, let's see, how do I execute them? I want to run them. Run all tests. See what I get. No tests were found. Oh, another thing that I have to do, which comes from importing these libraries, is I have to tell it which of these are tests. And I do that by decorating the function with an attribute @test. Now, when it gets compiled, all of the framework and everything knows that this function is a function that tests some other function. So now I should be good to go. I can right click. Where was it? Right click. Run all tests. So it runs it, and boom. It threw an exception. Index -1 out of bounds. Array index out of bounds exception. Anybody know why? Let's go look at this code again. So what does this function expect to get as input? Integer from, integer to, an integer value. What's it supposed to, what's it expecting? Remember up here, I'm expecting values from 1 to however many units I support, right? Not 0, but from 1. So when I pass in 0, and I say units from -1, and I say, give me the -1th item in this array, poof, it says I can't do that. Array out of bounds. Array subscript out of bounds. So, when I call this method and I pass in zeros, what do I really expect to get? I really expect to get an exception. So how do I test for that? Well, I don't know. So let me go Google. Or I'll just say expect exception. So here we go. Here's an example. We assert that it throws. So I'm going to call this, and I'm going to assert that it throws an exception, because that's correct behavior. Array index out of bounds exception. Am I supposed to use, oh, I guess I am. We haven't really talked about this, but I have to use these lambda expressions. They didn't have to do it that way, so I don't know why they did. Oh, yeah, so semicolon. Yeah. So now, if I run my test, run the test, now it says one test pass. Now, did I keep it from throwing an exception? No. It still throws the exception, but I wrote this test to expect for it to throw not just any exception, but that particular exception. The great thing about this is once you get a whole library of these tests built up that are testing your code, then your company hires next month a couple of interns, and they're in there banging away and checking in code, and they're eager beavers, so they're up at 2 in the morning and they're checking in all kinds of code, and it's all buggy. But then when they go to check it in, the build system runs all the unit tests that you've created against the code and dings them on every single one of them. It would even ding them if they change the code to throw a different kind of exception. No. Correct behavior is for that function to throw that exception when it's passed in those values. See how that works? Now, the challenge, and this is as much art as it is anything that I can teach you technique-wise, is to come up with, when you write your code, whatever functions it is, if you have 3 functions, if you have 30 functions in your code that you're implementing, is to look at every single one of those functions and come up with a good library of tests that define what's expected behavior under various sets of inputs and outputs, okay? Now, and you just start building up that library of unit test methods that, so there's, when you create a class, when you create a set of methods and properties and stuff in that class, you're defining the public contract with people who consume that class. The unit tests validate that contract, okay? And, you know, when you look at somebody, you know, the class that they developed, you can infer what they might have meant for correct behavior, but when you look at somebody's unit test, you can actually see precisely what they expected to happen with every set of inputs. Now, I mentioned before equivalence classes. So I've already got a test for passing in 0 values. Okay, well, that was very specific. But what if I want a test for yeah, well, very intuitive editor. If I want to test for negative values passed in, so I could pass in -1 for all 3 of them. That's one combination. Or I could pass in -1 for the first one and 0, 0. I could pass 0 for the first one. I mean, you know, there's lots of different combinations of passing in negative values that I could come up with. And this is where it becomes art and how you design your unit tests. So I probably want, I want a test that passes -1s for all parameters. That's this first one. Then I want one that isolates each parameter, passes in -1 for it, then maybe something not 0, maybe something valid for the other two parameters. Right, see what I'm getting at? I want to isolate each thing because I want to be able to uncover as many bugs as possible if if the behavior changes or breaks. So you need to think about different combinations of stuff. And one of the things psychologically about being a tester is, if you imagine, even when you're testing your own code, imagine that you're your evil twin and you're trying to just burn this code to the ground. You're trying to think of any possible way that you can embarrass the person who wrote this code by discovering every single little glitch and error and bug and mistake that person committed. If you can think of it deviously like that and you still can't find any bugs, well then the code's probably okay. What many developers get into the problem of doing is, when they design tests, they only test the happy path. They test for the expected values to return a correct answer, and they never go any broader than that. Sometimes you're lucky if you get that. I've had developers checking code that didn't even compile. So, okay, not only did you never see it work right once, you never even saw it compile. Now, usually it's not an intentional thing that they do. Usually they're guilty of the whole, okay, I've tested my code and it works, but I have one small little additional change that I need to make before I check it in. But it's a small change and I don't need to go retest everything. That's usually what gets them in trouble. It's like, well, you should at least compile it. So, but you don't want to be in that mentality when you're the tester, and even when you're putting on the hat of the tester of your own code. Because if you go to all this trouble and you try to deviously come up with as many test cases as you can on your own code, and you've defined what correct and incorrect is, and you've codified that contract, how can I find anything to fault you with, right? You know, it's sort of like, you know, if your sergeant can't see you, neither can the enemy. Same thing. If you unit tested your code and you can't find any bugs, well, the teacher's unlikely to find any either. But that's what I wanted to show you this time specifically, is how to create a unit test, different kinds of unit tests. I mean, obviously this one isn't completely fleshed out yet. You'd have to go and, you know, every unit test is call the code and then define what you expected to happen and assert that that's what happens. And if it doesn't assert, then that test is going to throw. So I would need to do the same thing here. I would need to say assert equals, or assert throws, whatever I expect it to do. Now when I pass in a negative value, just like when I pass in a 0 value, it's going to affect the array subscript. So I'm guessing that I'm going to get the exact same array index out of bound exception for all of these cases as I did for this one. So it'll probably just be copying and pasting this code to test these use cases also. And then, you know, additionally, I do want some that test for correct behavior. I would want to test for converting inches to each one of those other units. I would want to convert from each of those other units back to inches. You know, I would want to flex them all. And I guess getting back to the mention of equivalence classes, don't think exhaustively that I have to try every single value that is possible with test cases. No, you don't have to test exhaustively, but think representationally. Zero values being passed in is a description for a possible bug. If I pass a 0 in for one of these parameters, it could cause a bug. If I pass a negative value in for one of these parameters, I could cause a bug. But I don't also then have to test -2 and -3 and -4 and no. I've already passed in a negative value, so I've already hit that equivalence class. So, yeah, that's the point I was making there about equivalence classes. And imagining what those equivalence classes are and coming up with a concise, you want as many test cases as are required to thoroughly test the contract and no more. You don't want any extras. You don't want any missing, but you don't want any extras. You want exactly the right number of test cases. Okay, so I think that's what I wanted to cover tonight. There's lectures out there for the next unit. If you finish this next assignment and you want to get started on the conditional stuff, the lectures are already out there. Feel free to go watch those. And I will stop this here.